My name is Martin. I'm CEO and co-founder of Example42. So people who know Puppet for quite some time will recognize Example42, Alessandro and me, as being the Puppet dinosaurs. So doing Puppet since more than 10 years by now. And that makes us somehow a well-known community member within the Puppet ecosystem. And a couple of months ago, I attended a Berlin-based meetup. And people were showing up and saying, hey, Martin, do you remember you did a training a couple of years ago for covering Puppet knowledge and sharing Puppet knowledge? I said, yes. So how are you doing with Puppet? Oh, Puppet is working flawlessly, but we made an architecture decision, and we're now going for cloud native. We're using containers by now. And you know what we learned? When we do containers, we eliminate the need for DevOps. So we don't have to do DevOps anymore. This communication thing, that's only a waste of time. We just do stuff. And I said, okay, wow, interesting, nice. And that conversation gave me the idea of providing a talk about DevOps in a containerized world. Everybody might remember the past. So who might think about having legacy or heritage platforms, how we call it nowadays, long-running systems, our beloved pets that we take care about. Then we have development processes taking place, first as the planning process, then the development process, then the release process. Developers were working with a concept called waterfall, so everything is flowing silently, and somehow they finished work, and they throw everything down the waterfall, down to ops. So we have 3 months of planning for a release, 3 months of developing a release, and then we have 3 months of deploying the release. And then everything repeats from the beginning. Yeah, but companies were quite unhappy with this process because they learned, we put too much stuff into this huge release in this long-term cycle. What is it that we want to do? We want to have login via Facebook, we want to get some insights, we want to upgrade a database that's running in the background, everything in a single, squeeze it into a single release, and that takes time to deploy. And one day market management asks their product manager, okay, what about the new version of the new release of our application that's running outside? Do we attract more users? And product has to confess, no, they are switching over to that other solution from another company because they have deployed everything within 6 weeks and not within 6 months. Yeah, how could they dare? Why are they so fast? Basically, it's because they have changed the way how they deal with infrastructure and with changes by adopting, DevOps. So who of you knows what DevOps is? Only a couple of people? Okay. Who does DevOps on a daily basis? More people, okay. Who is a DevOps engineer? Still a couple of people. Interesting, I need to talk to you afterwards. What is a DevOps engineer? But that's another topic. Okay, so the concept is they have switched from waterfall to agile development, allowing for faster releases. So now the developers show up at the ops people saying, hey, we have some fantastic news for you. You know the past? Every 6 months you receive a new release. We're changing that. You get a new release every 2 weeks. Oh my God. Every 2 weeks we have to do a new release. How should we do that? We are struggling hard with getting the release, the large release done in time, and now you're saying you want to release faster? Then, it's easy. Just implement DevOps. So just do some collaboration, automate the stuff, so don't do manual updates, automate your updates of your applications. And the best approach to see DevOps is when you, within a company, when you say everybody is a customer. Okay, I know this from sales, they are squeezing customers hard to get the most out of the customer. Okay, be more precise. Let's everybody deal with a trusted and honest customer. Maybe that's a better term for it. So what do I understand when I say everybody is a customer within one company? We say the product owners want to have something. So they have money and they bring it to development and saying, please develop, this is the money for the time that you spend over there, please develop an application for us. So from developers' perspective, both are customers. One has a desire and a need, and the other has the knowledge how to do it. When development has finished, or even a little bit earlier, they're heading over to ops and say, here is a new release, we're planning a new release, please run this application for us. So again, a customer relationship between each other. And there's one specific special department where we say everybody is a customer to that specific department. For developers, they want to ensure that the application is working properly and secure, that it is compliant to some kind of policies, standards, or even laws maybe. And ops want to know that they also follow the security principles under which they should run applications. So both head over to security by saying, please guide us. So again, it's a customer relationship. This is what we call DevOps, or some people even refer to as DevSecOps. So yeah, just stick to DevOps. Security is related everywhere. So DevOps is already fine enough. We don't have to mention security. Security is everywhere. So for the DevOps, some people might know about 4 terms which are referred to as CAMS, C-A-M-S. That's culture, automation, metrics, and sharing. And I don't like the second 2 words, so I prefer the term kata. The term kata is kata itself is a term that comes from martial arts. Kata is a repetitive learning pattern you're doing in a dojo. The dojo is the place where you learn martial arts like kung fu, judo, karate. And kata is something that you permanently repeat a movement, what you have to do. And the same is for me for DevOps. It's a permanent, repetitive learning pattern. You always have to adopt to what you've done in the past, what you've done last week, what you've done a few seconds ago. And this kata is an abbreviation. The first thing is called the culture. The culture is the way how we deal with each other. The culture is personal culture. It's not tooling culture, it's not politics culture, it's personal culture. How do we deal with other people? Respectful, listen to them, listen to everybody, even from another department. Maybe they have other ideas, they have other sides on things which you, by being so involved in the stuff, have completely forgotten and lost out of sight. If they are wrong, guide them in the right direction and teach them what they don't know so that next time they don't come up with wrong ideas. This is for the technical people. The same accounts for managers. So someone around being a manager here? Just a couple of shy hands showing up, okay? So as a manager, usually I know managers being bosses. So they get topics from their top-level management and they say, this is the things you have to do, you only have that amount of money and that amount of time and things must be done. And now push the team hard to achieve the goals. And the more you push, the more will be your benefit, regarding your salary, for example. Within DevOps, this changes completely. When I have a DevOps team, and I'm looking for the manager is a shielding coach for the team. So the manager has hired people with specific technology skills. So there's no need for a manager to micromanage his team. The team knows what to do. They have the technical expertise for doing so. The manager should be there for coaching the team, so about new things they might learn. How should they deal with each other? He should shield them from anything that comes outside the team. Everybody who wants to push something into the team must first be the manager saying, I'm objecting, I'm here, first talk to me. Don't talk to my team. I'm shielding my team from anything ugly that might happen. Even if you want to just send complaints to my team, don't send them to my team, send them to me. I'll take the complaints. If you want to talk good about the team, then of course I will take care that this communication is passed on to the team so the team knows that they did a good job. So the thing is for managers, guide and coach and not push, so we don't have bosses anymore, it's only coaches we have at hand. That's the culture part. The next part we do in automation, where I fully align with the CAMS construct, is the automation, where we just say automate the initial setup, automate application deployment, automate application updates. Please, when you're running on virtual machines or even physical hardware, also consider to automate some tear down of things that are no longer in production. Just automate the stuff. This is where we're using Puppet for configuration management, for initial setup of systems. Automate the stuff. And now are the points where I differ from the CAMS construct by saying metrics and sharing is both the same for me. Since therefore I call that transparency. Be transparent in what you are doing. Provide information to everybody. Whether that is a sales department that want to know how many users do we have actively on the platform, just provide them metrics and visualize them in a dashboard. Metrics for the marketing team, they want to learn how did the last marketing engagement go well? Do we have more users? Do we have more income? It's just data. And you make a transparency by sharing the data. You make a transparency by sharing your code. You can have people only with view access on your Git code, for example. You put in version control, but everybody can see what you are doing. Yeah, but what about private data, certificates, passwords? Protect these. Somehow protect, but not hide. Everything you're hiding is something which for other people is not obvious that things are happening on a platform. So that's the transparency part of the cutter. And the last one is be agile. Agile in terms of methodology, how you're working, not agile in like of minds. Today I'm doing Puppet, next week I'm building a house, next week I'm doing road construction. That's something completely different. But being agile in a way how you see your work. Split huge things down into simple to do, easy, small tasks. So this is what I refer to as the DevOps Cutter, what I call the classical DevOps approach you have when you have some kind of on-premise infrastructure, even maybe hardware-based. When you do DevOps, you want to look for specific toolings. And what we found out with some customers is developers have a set of tools they want to use for their purpose. Another team has another use case for other tools. A third team made a decision, oh, we also need a version control, but we don't trust the developers, we build up our own. So now you're building DevOps silos, which is not really what you would like to have at all. So take care, sometimes it might be possible that one team needs a tool that other teams do not require at all. But try to use shared tooling wherever possible, because that provides shared knowledge amongst the tools, and you can share knowledge among different teams about how things are working. What is it that you need? The first thing you want to for sure have is version control. And what I usually explain to my customers is what's not in version control may never be brought to a production system, because that means that's a manual approach and nobody knows what you are doing, you're hiding stuff. The next thing you want to have is configuration management. For example, Puppet. Sometimes you have workflow-based stuff. This is what you do with Bolt. Then people show up and saying, but keys of certificates, passwords, this is not something we would like to have somewhere in plain text so everybody can read and fetch the information. Somehow they leak maybe. You also need some kind of secrets management. And then it's up to you whether you use Hira-YAML, for example, or even have a vault somewhere around. Was one part of the tooling. You need more toolings. You want to have some kind of VM management. Think about a self-service portal. So just having a VM management, yes, we have VMware, and over there's the silo that creates VMs based on tickets that teams have to write. One customer needs 50 VMs, so they have to write 50 tickets, 50 identical VMs, 50 identical tickets. It takes 3 days to 3 weeks to receive 50 VMs, and afterwards they recognize one has too much CPU, the other has too few RAM, one is having a disk, the other one is missing a disk, the next one has a disk, but it is too small. What is it that they have to do? They have to reopen the ticket saying the system is not in the state as we expected, so the VMware team can tear down the VM. They have to open a new ticket to get the proper VM. That's not really a DevOps approach. That is silos that don't communicate with each other. It would be far more better if the VM management team would have built some kind of self-service portal where developers can say, hey, this is what we need. And we have a certain pool of hardware, and this is where we can deal with and just deploy systems on top of it. You want to have metrics. You definitely need metrics. Ops needs metrics regarding disk space, CPU usage, technical information from the systems underneath. Developers might need metrics for, is the application working? How long does a TCP request from one system to another take? How long SQL queries? How long do they take? Can we optimize them? You need other things like product want to know, are customers buying or are customers somewhere interrupting the step to buy, and on which step do they do this? So this is all about metrics. Marketing wants to know, do we have new users after last week's campaign? All about metrics. I forgot about a very important department, finance. How much spendings do we have in the cloud? What is the forecast for the next 3 quarters? All about metrics. And then we come to something, and this is not a typo, please, CI/CD systems. So everybody knows about continuous integration, like RSpec Puppet testing their code, whether it really compiles. Then most people do the first CD, which means continuous delivery. It just means from an application developer view, I'm regular building RPM packages and place them to a repository server, and then I'm done. Nice, now you have the packages on the repository server, but we don't need them on the repository server, we have to deploy them. And this is the last CD that we say continuous deployment. Every time you test something, you build something successfully, deploy it. So that's the CI/CD system you need at hand. And as you have already seen, application developers need it, infrastructure developers need it. Within that, we come to the point that we have, in classical DevOps, a shared responsibility for hardware. Hardware shared responsibility? Yes, if you run on hardware, you ask your developers about what recommendations do you have on the hardware sizing for the new application that you're building. You need information from them. That's a shared responsibility. Operating system is a shared responsibility. Maybe the marketing department shows up, say, can you run internally an application for us? We're buying it from a vendor. You say, yes, for sure. We're spinning up Linux machines. Okay, it has a specific database backend. Yeah, we can run Postgres, no worries. No, it must be MS SQL. Oh, okay, so we have to spin up Windows systems. Again, a shared responsibility. And of course, the application, like we already did in the past, we have the monitoring. People refer to monitoring. I like the term metrics, because with monitoring, you do alerting, the same you can do based on metrics. That you have a view of, are the applications working properly? The problem is with this approach, it's a hard learning curve, especially Git. When doing Puppet trainings, I spent, let's say, on one day, half of the day, it's a 3 days training course, and on one half day, I need to explain the concepts of how Git is working at all. You have to reconsider your infrastructure, not running SSH remote command executions anymore, but using API-driven infrastructures, ideally an HTTPS API may be based on certificate authentication or authorization. People have to learn, usually we're saying, never touch a running system. Who knows that term? Never touch a running system. Only a few, okay. I like nowadays to revert the term by saying, never run a touchy system. So never run a system where you have to do things manually on top. So do changes and do these fast. Do not wait weeks or months until you can do the first change. Do it fast, as soon as possible. And this is a huge paradigm change for everybody working in IT, working as learning about DevOps. Okay, this is physical hardware. This is from the, how old am I? 1980s, 1990s. We now do cloud. Okay, so what does now change DevOps when we do cloud? Nothing. One thing. You have finance involved. Why do we need finance involved when doing cloud? This is technology. It's not finance are paying things. And yes, they are paying things. They are paying your cloud. They are paying what you need on the cloud. The cloud is foreign computers, and you just rent them for a certain period of time. And finance definitely needs some forecast, some overview. What is the actual spending? What is your planned spending for the next couple of months? They might also make you suggestions whether a cloud really is less expensive compared to running it on-premise. They think about terms like CapEx and OpEx, capital expenses, operational expenses. What the hell is this? It's finance related. It's their field of expertise, so listen carefully to them. DevOps culture, listen to them, teach them, and again, they will teach and coach you in doing the right things. All the toolings that you have, they still remain the same, and you still do DevOps. Okay, now let's call this then something like product development security finance ops. prod dev sec FinOps. It's horrible to spell, so let's just use the term DevOps, full stop. So the summary is, we have classical DevOps to get standardized systems that follow policies, that follow rules, that follow laws from security perspective. Whether these are on-premise or off-premise make no difference at all. Whether it's private cloud or public cloud, regardless, you still do the DevOps principle. This means you have a collaborative way of working together, setting up systems, maintaining them, managing them, upgrading them, tearing them down. Okay, and now we have this new world, containers. Someone mentioned containers once. So why do we have containers at all? Developers learned by this DevOps principle how hard it is to maintain a proper infrastructure where we run applications on top. So they thought about, let's separate this. On one hand, we have the application. On one hand, we have the operating system. And we just have some kind of container runtime engine as the interface between operating system and applications. If you ask BSD people about containers, they will laugh out loud. And you mentioned this is something totally new. They say, we have this since ages. It's called jails, by the way. So sys separations, that's the reason why people believe with containers we don't need DevOps anymore, because developers are doing applications. They build applications, they deploy applications, they monitor applications, all within development field of expertise. On the other hand, you have the operations people that take care on data center, infrastructure, network, storage. Oh, we are in cloud. Everybody's managing this for us. We just buy it. Okay, maybe you have some legacy systems, so it's still managed by ops. Container infrastructure means you have to do software-defined networking because this might be fast-changing infrastructure. You don't want to wait for network engineers till they have put a VLAN on a port, on somehow a switch or router or someplace like that. Containers need orchestration, definitely. You do not want to have one system running one container. You want to have high availability also on containers. And again, you have the change that you're monitoring for services and no longer for systems. So this again requires a new thinking on how infrastructure is working, from development, from security, from network, and from operations team. So they need time to learn and adopt to the new things. If you haven't done DevOps before, they don't have free time because they still have what was the soul-crushing jobs they have. So what Yvonne said in her keynote. So they still deal with issues every day. They are more firefighting than being productive. That's the reason why we had DevOps at all. And now they have more time dealing into modern technology and how things are working properly, not just working. So people say, it's more cloud native, it's more easy to migrate from one cloud provider to another, from an on-premise to an off-premise cloud. Dev can isolate issues within the application. Ops isolates issues within infrastructure or identifies issues within infrastructure. Security just provides some information on kernel capabilities, seek groups. Network engineers are just building the interface between there's the wire and here we have the SDN. Developers now need to have some CI/CD system, same we used already for Puppet, we can reuse it again. They just need some kind of container registry for continuous delivery, and they need access to either container runtime API or to a container orchestration API doing continuous deployment. Developers are responsible now for staging and reverting applications. In case that the application is not working, please use the last known version that was working. They are responsible for performance and availability, so don't run this application in debug mode. Who has enabled the debug mode in the last commit? I don't know, Git blame will tell me. Ops is responsible for sizing and storage, for the hardware underneath, or even maybe for the cloud accounts so that they deal properly in cloud. Ops is responsible for providing access to the infrastructure, like a Kubernetes cluster. So there we have team, why Ops and not security? Why not developers by themselves? It depends. This is at least this approach that we saw at one customer, that Ops provides namespaces to developers. They manage the infrastructure and they just have namespaces in the Kubernetes cluster saying, there's the production cluster, that namespace, there's the development cluster, another namespace. Network takes care on the networking stack, so isolated everything from each other. Finance does the budget, and security. Security is almost everywhere. Not almost. Security is everywhere. Whether you do application deployment, whether you're building infrastructure, whether you're designing networks, whether you're designing access to certain applications, security is always involved. So this is still something what we would call SecDev and SecOps. Why not name it SecDevOps, or why not name it DevOps? Again, the same counts for tooling decisions. Everybody needs a CI/CD system. Everybody needs some kind of tool, a machinery that takes care on automating processes, even if it's foreign infrastructure. You want to have some kind of secrets management. You want to make infrastructure decisions. So people asking, developers said, we need some storage for data. And they said, yes, there's a file system. No, we need a block device. Oh, you should have told us upfront. So communicate upfront, again, now even developers and operations, that they get the proper storage system, whether they need a block device for databases or a file system for real files. So DevSecOps is the key where everything comes together. Security ties everybody together. And when someone tells me in a containerized world we have that, and we don't need to do DevOps, they completely omit security in everywhere. So that's the reason why I say we still need everything together. We still need DevOps. We still have to follow the DevOps Cutter. Depending on how much you do, how fast you work, how much hardware you have, you might go for something like serverless and opsless and buy everything as a service. So having platform as a service, for example. This is a startup mentality. So it can happen that these companies don't have any ops teams at all, but then it's part of the security and the development team that ensure that the infrastructure is running properly. If you're an older company, you might have some kind of heritage system, like some outdated DB2 installation in the background that must run for the next 10 years due to provide data for finance, for example. Summarizing first. Whenever you do things in a platform, it was fun when I had my very, very first job. It was a consultant in finance area in Germany. And on my first day, I got introduced to a couple of people around there whom I have to collaborate with. And there was one person sitting there wearing a suit, a bow tie, nice hair, everything's great. And he said, Mr. Alfke, take care of the KISS principle. If you don't know what the KISS principle is, Google for it. Of course, I didn't know what the KISS principle is and Googled for it. And it means you have something complex to do. Every platform gets complex sooner or later. If you build the platform complex right from scratch, it will be complex very fast. If you build it out of simple pieces, then it will be hard to make that platform complex because you have lots of simple functional pieces. So DevOps in a containerized world is not dead. It is even needed more. We need more communication upfront. We need more shared tooling. People are working now as, I've heard people talking about YAML ops nowadays, as we only write YAML data. So having Git ops with YAML ops somehow enabled. It's more needed because you might have one file where different departments provide information together, which build your containerized world. It's a steep learning curve for everybody. And again, we have this product development, security, operation, finance, and even management somehow should be evolved. Consider your managers being coaches and not bosses. So they shouldn't lead a herd. They just should promote you in what you're doing when you're good at. Everybody needs insight. Everybody needs information. That's the transparency that you still have to build up. Last slides. The conclusion. So DevOps is not dead. That is something we already had. So when you're building containerized platforms, when you're building standard platforms, find tools that integrate properly, that have an API so they are able to communicate. Prevent the not invented here syndrome. I see so many companies that building things from scratch where they say, why? There's open source tools around that already do the same thing. Yeah, but we have time. At the moment, you have time, and afterwards, you're stuck with updating and fixing and security fixes. Not nice. Build something like Puppet for configuration management. This is the declarative way. Use Bolt for anything which is related towards workflow-based, like application updates. The nice thing, when you integrate it with enterprise, you can omit OpenSSH access to the machines, something security will really like you for. You want to have continuous delivery, continuous deployment. This is what CD4PE is meant for. You want to give insights for security for everybody. Use Remediate. You want to do cloud or even cloud native. Check out Project Nebula. I have been given access day before yesterday. I still have to look inside what it is capable of. What else is it that you need? Everything else is modules in the world. That's the reason why there's Vox on the table, because we have Vox Populi, the community that provides modules. Whether you use legacy platform with Splunk, we have one customer using Docker in their CI system, applying these with Puppet Labs Docker. We have one customer building an on-premise Kubernetes cluster because he's not allowed to go into cloud using the Puppet Labs Kubernetes module. You want to go to AWS? Don't build a Puppet enterprise server by yourself. Head over to the marketplace and just click it and have it within seconds. So DevOps is not dead. DevOps is even more needed than ever. The problem is not the tooling. The problem is the people. So coach each other, help people understanding your problems, and listen to other people to understand their problems. Thank you.